All right, let's get started with Casper Andreas, who is going to present his work in collaboration with his co-authors on applications of human multi-robot systems in search and rescue and in farming. So Casper, you can start whenever you're ready, and make sure to be within the 3 minutes limit.
I'm a PhD student under Anders Christensen at the University of Southern Denmark. And I'm going to talk to you about the HERT project, which is an abbreviation for Human AI Collaboration, Engaging and Controlling Swarms of Robots and Drones, which is a project which aims of enabling humans to collaborate with swarms and control the swarms efficiently. So yeah, we want to enable the end user to engage and control the swarms. It's a project which bridges between the industry. So we're not only trying to implement swarms in the laboratory, we are trying to bring the robotic swarms out into the real world, and making the operators able to control these swarms efficiently in two scenarios. One of our industrial collaborators is a company called Roboto, which does search and rescue and fire monitoring, and the other is a farming robot which does horticulture farming, which is industrial farming. By the end of this project, we want to have, as I mentioned, a real-world experiment using our industrial partners' hardware platforms, which in this case is a DJI drone, one of the large ones with multiple cameras, both thermal and the visual spectrum cameras. The other is Agrancellis, a mobile platform, which is a ground robot with a very, very high precision to be able to navigate through rows of crops and so on. And yeah, we want to in these multi-robot systems, it can be hard to gain situational awareness, especially when they get this external actors, such as in search and rescue scenarios where you have helicopters, ground personnel that's searching on the ground as well. How do you keep track of all your resources from an operator perspective? And how do you do the planning, both pre-operation and on-the-fly planning with the operator in mind? During such an operation, you would often be challenged with unforeseen circumstances, and then we want to enable the operator to create do the best action possible. One of our early studies were in collaboration with the Danish Agency of Emergency, and here we got some insight from how they want to control such robots. And you can see from one of our early prototypes, we want to do some coverage in a specific area in the image to the left, and the other one on the right displays the trajectories of all the robots, which can be very, very hard to monitor for the operator. So we want to develop a system that's able to display all the necessary information efficiently, and we are still working on that, ongoing work. That's me. Thank you so much for your attention.
Thank you very much, Casper. And next speaker is going to be Emile. Is that right? Emile Fleischer or Alexander?
It will be me, Alexander.
Alexander. Okay. Please go ahead and share your slides, and you can start whenever you're ready.
Okay. Can you confirm you have a visual?
Yes, we can see them.
Okay. Good afternoon. So the IROS project is a European project aiming at developing an architecture for future military manned-unmanned teaming with ground robots, aiming at being scalable, modular, and enabling interoperability. And it is being demonstrated on the field. And to give you a bit of context, we have a mobile command post which hosts the fog layer, network layer, together with the human operator, with a human-machine interface where he can interact with the system. Communication goes through radio and our 5G with the edge devices, namely the ground robots, which all have an autonomy module for handling autonomous functions like obstacle avoidance. And the control can be by teleoperation or with a multi-robot module, which is the main focus of our paper, which is mainly composed of the following. So in the fog, on the mobile command post, we have a swarming or multi-robots module, which has a mission orchestrator for interpreting the operator's intentions and mission objectives. And it is articulated around the concept of mission, where multiple instances of mission management processes are instantiated in parallel with their individual state machines and processes. With that, we have the mapping and planning processes with the metric to topological graph transformation, with the multi-agent planning algorithms, swarming algorithms in a centralized way, so all in the fog. And then on the edge, for managing the edge devices, we have a fleet management process for sending tasks, gathering feedback, and doing the connectivity management. On the edge devices, we have mainly the task execution supervision process in the case of a but when communication is not available, for example, in radio silent zones between fog and edge, there is a decentralized approach which can be switched on. Local communication can occur or none at all, where team state estimation needs to be done. But of course, it then incorporates more of the fog modules like the mapping and planning processes. So thank you for your attention. If you have interest, there's a demonstration video available and referenced in our paper.
Thank you very much, Alexander. And our last but not least presenter of the day, so that's the 12th, I think, presentation that we're listening to, will be Sarah Huren, I think.
Yes. Hello.
Thank you very much.
You hear me?
Yes, yes, we can hear and see you.
There is no echo?
There is echo, actually.
Just a moment, because I have problem with the camera. I will have to leave this. Okay, leave the meeting. It's okay.
Yeah, I think if now, you speak slow enough, it's okay. Perfect.
It's perfect. Okay.
No, now it's perfect. Yes, yes, indeed. You can share your slides and start whenever you're ready.
Okay. Sorry for the few seconds lost. It's coming.
All right, we can see your slides.
That's okay. Hi, I'm Sarah from CDTA in Algeria. I'll talk you about a challenging issue in human multi-robot system that concerns motion safety. Recently, human multi-robot systems are revolutionizing several areas, mainly industry, service robotics, where humans and robots share the same spaces and collaborate. The new tune is to bring together the human intelligence and the robot efficiency to enhance the performance of the working team. When robots are navigating autonomously among humans in real conditions, guaranteeing motion safety is primordial, especially in dynamic and hazardous environments crowded with robots and humans with arbitrary future behavior, and for robots having a limited field of view, including occlusions. The aim of this work is the motion safety guarantee of the human multi-robot system. The question is how to guarantee motion safety for multi-robots evolving among humans. Generally, in such condition, absolute safety is in the sense that no collision will ever happen, is impossible to guarantee, as it requires knowledge of the future up to infinite. The answer is to propose a solution that can be executed by both the robot and the human. The position taken in this work is passive motion safety. It guarantees that an eventual collision will never occur as long as the system is in motion. It is obtained by avoiding braking inevitable collision state, defined as state for which, whatever the future braking trajectory of a robot, a collision occurs before the system is at rest. Therefore, the proposed approach is a generalized version of the braking ICS adopted for human multi-robot systems, dual-bit multi-braking ICS. This is the definition. Braking ICS is applied to each system in the human multi-robot system. As the natural behavior of human when encountering a collision danger is to stop, it is applied to both humans and robots. Multi-braking ICS guarantees that all the system can stop before any collision. In this case, any collision will ever happen. To conclude, it is important to emphasize the advantage of multi-braking ICS with respect to the basic braking ICS. You see here in the right, the robot stop. However, a collision occurs. The robot is not responsible. However, in the case of multi-braking ICS, no collision happen. What is ongoing is the implementation of this approach in a hospital application using a smart wheelchair and assisting robots. Okay, thank you for your attention.
Thank you very much, Sarah.
You're welcome.